In this problem, we're asked to predict a Le Chatelier shift in equilibrium position that would occur when the following changes, or when the volume of the container is increased. If the volume of the container is increased, we can say that the pressure of the container is decreased, which is very important. When considering gases, if there's an increase in pressure, the equilibrium shift will be to the side with fewer moles of gas. But the opposite is true when there's a pressure decrease. When the pressures decrease, we would see a shift to the side with more moles of gas. Keep that in mind. Okay, so let's take a look at part A. We're just going to count number of moles of gas. So 4 moles of gas on the left side of the equation, and on the right side of the equation, 2 moles of gas. If pressure is decreased due to the volume of the container being increased, then we'll see a shift to the side with more moles of gas. And in this case, that would be a shift to the left, to the side with 4 moles of gas. Next one, we've got 1 mole of gas on the left side and 2 moles of gas on the right side. We're shifting toward more moles of gas. And since the difference is between 1 and 2, we'll shift to the right, which is the side of the equation with 2 moles of gas. Question C. We have 2 moles of gas in hydrogen and fluorine and 2 moles of gas in hydrofluoric acid. Aha! We have equal numbers of moles of gas. So the volume of the container increasing or decreasing when the pressure changing accordingly will not affect this equilibrium position. It'll stay right where it is because there's equal numbers of moles of gas. That's not to say that there won't be individual molecules that will be reacting from one side of the equation to the other, but there's no net change. Okay, question D. We have 1 mole of gas on the left side and 2 moles of gas on the right side. And once again, if pressures decrease due to the volume of the container increasing, then we shift to the side with more moles of gas, which is to the right. Lastly, question E. Notice that we're only keeping track of moles of gas. That doesn't mean solids can't react, they certainly do. But in our accounting, we're only looking at moles of gas. So in part E, there's a solid on the left side, and a solid and 1 gas mole on the right side. And if I'm only keeping track of gas moles, I'm just recording 1 mole on the right, so a pressure decrease would cause a shift toward that side where there's more moles.